All right, let's dive into one of the most mind-bending and honestly revolutionary technologies on the horizon, quantum computing. This isn't just a small step forward, it's a technology that could completely reshape everything we know, from medicine to material science, all the way to how we keep our secrets safe. So buckle up.
I want you to just think about this for a second. Imagine a problem so incredibly complex that our fastest supercomputers today would need longer than the entire age of the universe to even crack it. Now, what if a totally new kind of machine could figure it out in just a few minutes? And believe me, this isn't science fiction. This is the wild promise of the quantum world.
So how on earth is that even possible, right? Well, it all boils down to a totally different way of thinking about information. See, the computer or phone you're using right now, it thinks in a very straightforward way. It's all black and white. But quantum computers, they get to play by the wonderfully weird rules of quantum mechanics.
And the difference starts right here, with the absolute basics. A classical computer uses bits. A bit is just a simple switch. It's either on or off, a 1 or a 0. That's it. But a quantum bit or a qubit, now that is a whole different ballgame. Thanks to a wild idea called superposition, a qubit can be a 0, a 1, or, get this, a blend of both states at the exact same time. It's not just on or off, it's in a state of on and off.
This single idea that something can exist in multiple states at once is where all the incredible power of quantum computing comes from. So let's zoom in a little closer on these bizarre, almost magical properties that make qubits so incredibly special.
Superposition really is the secret sauce. Until you actually measure a qubit, it just hangs out in this cloud of possibility, holding all its potential values at once. It's only the very act of looking at it, of measuring it, that forces it to pick a side and become a definite 0 or 1. Before you look, it holds a ridiculous amount of information.
And here's a brilliant way to picture it. If a normal bit is like a light switch, it can only be up or down, a qubit is more like a globe. A bit can only be at the North Pole, let's say that's our 1, or the South Pole, our 0. But a qubit, it can be anywhere on the entire surface of that sphere. That means it can represent a practically infinite number of states in between.
Okay, so how do we take this cool trick and turn it into something truly powerful? Well, you take superposition and you combine it with another, even spookier quantum phenomenon called entanglement. And that is what unlocks this almost unimaginable processing power.
So here's the crucial takeaway. Because every single qubit can hold both a 0 and a 1 at the same time, a quantum computer with a bunch of qubits can explore a massive number of possibilities all at once. It's not checking things one by one, step by step like your laptop does. It's like it's evaluating every single path, every single option, simultaneously.
And this is where the numbers just get insane, in the best way possible. If you have n qubits, you can process 2 to the power of n calculations at the same time. Let me put that into perspective for you. A quantum computer with just 300 qubits could explore more possible states at once than there are atoms in the entire known universe. Yeah, that's quantum parallelism.
And then there's entanglement. This is where things get really weird. It's when two qubits become so deeply linked that they share the same fate. If you measure one of them, you instantly know the state of the other one, even if it's on the opposite side of the galaxy. Einstein himself called it spooky action at a distance, and for a quantum computer, it's an incredible tool for linking information together.
Okay, so we've got all these mind-bending properties, but what can we actually do with them? Let's take a look at how special quantum algorithms can just chew through problems that are flat out impossible for any normal computer. And this is where you really see the game-changing power. Look at the encryption that protects our banking and online data. It works because it would take a normal computer billions of years to figure out the huge numbers behind it. But a quantum computer, using something called Shor's algorithm, it's perfectly designed for that exact problem. It could solve it in minutes. And for searching huge databases, Grover's algorithm offers a massive speedup. It's not just about being faster, it's about being fundamentally different.
So, if this technology is so powerful, why don't we all have quantum laptops? Well, here's the catch. Actually building one of these machines is one of the biggest engineering challenges humanity has ever faced, because it turns out qubits are
The number one enemy, the biggest problem by far, is something called decoherence. You can think of it as the arch nemesis of quantum computing. It's the one thing that's constantly trying to wreck the whole process. Basically, any tiny interaction with the outside world, A stray vibration, a tiny fluctuation in temperature, even a random bit of electromagnetic interference can cause the qubit to decohere. It loses that magic superposition state and just collapses into a boring old classical bit. The whole calculation is ruined. So the main challenge is just keeping these qubits perfectly isolated from the noisy world around them.
But despite how hard it is, the race is absolutely on. All over the world, scientists are trying out different ways to build stable qubits. Some are using powerful electromagnetic fields to trap single atoms. They're called ion traps. Others are using special mirrors to trap a single particle of light. There are even approaches that use tech similar to an MRI machine. Everyone is trying to find the best way to tame the quantum world.
So when all is said and done, here's the big takeaway. Quantum computers aren't just about making things faster. They represent a whole new way of computing, of interacting with reality itself. They could help us discover new medicines, invent impossible new materials, maybe even solve some of the deepest mysteries of the universe. So the real question isn't just how fast they'll be, but what incredible new worlds they'll allow us to discover.